Hello, my dear students. Welcome to our channel Easy Chemistry. And today our topic of discussion is the zeroth order reaction. Okay, so let's see what happened in zeroth order reaction. And before starting of this class, I'll request my dear student to please keep your notebook handy. Okay, and try to write down the things I will write on the whiteboard, otherwise it all forget you. Okay, mind it. Practice makes you perfect. So what is zero order reaction? Let a reaction, let a chemical reaction new one A to P. Let this is a chemical reaction new A to P. What is new? New is the stoichiometric coefficient of A. That means from new moles of A, 1 mole of the product will be formed. So new, what is new? New is the stoichiometric stoichiometric coefficient. Stoichiometric coefficient. And let the reaction is zeroth order. Let the reaction is of zeroth order. So what does it implies? It implies that the K is the rate constant. So the rate of the reaction, what will be the rate? Rate of the reaction R will be minus 1 by nu dA dt. This is the rate of the reaction, and this is basically the differential rate equation. This is not the integrated rate equation, rate law. This is the differential rate law. And mind it, we assume that the reaction is zeroth order with respect to what does it implies? The reaction is of zeroth order with respect to reactant A. Okay, so R equals to K to the power K into A to the power 0. Look, my dear students, here nu is the stoichiometric coefficient, but the power of the concentration of A is 0. This is so these are the not same. These are not same. So the power of the A rises to 0. Why this rises to 0? Because we assume that the reaction rate is zeroth order with respect to the reactant A. So R becomes K. That means the rate of the reaction does not depend on the concentration of the reactant if the reaction is of zeroth order. Okay, so what the rate of the reaction, the rate of the reaction does not depend on the concentration of A, as it is of zeroth order with respect to A. So actually this is the physical significance of a zeroth order reaction. The rate of the reaction doesn't depend on the concentration of the reactant. So what we get? The equation 1, this is equation 1, and this is our equation 2. So 1 and 2 are the similar. So comparing equation 1 and 2, equation 1 and 2, by comparing equation 1 and 2, what we get? We get R equals to minus 1 by nu dA by dt equals to K. My dear student, write down the things I have written on the whiteboard. I think the board is quite visible. If the board is not visible or the board is visible partially, you can write down your difficulties you have been facing in a comment section. I'll manage to remove all these difficulties, or I'll manage to overcome all these difficulties. Okay, so let's move forward. So this is the equation 3. So now I am removing the upper part. I think you have managed to write down the things. So from equation 3, what we get? So what we get minus 1 by nu dA by dt equals to k. So we just rearrange this. So dA equals to minus k into nu into dt. Now try to integrate. So when time, here the two variables, there are two variables. What are the variables? Time and a. So t is the dependent independent variable, time is independent. Time is not in our hand, time is progressive in nature. So time is the independent variable, and this is the concentration of the reactant, which is the dependent variable. So there are two variables, time and concentration of the reactant. So when time is 0, the concentration, we let the concentration of the reactant is a 0, and when at any time t means the observation time. When you are observing the equation, or when you are observing the reaction, this is the time t. So at the time t, the concentration of the reactant, let it is A. So now performing the integration, we get, this is nothing but A minus, and taking the limits, upper limits minus lower limit, and here also k nu t, okay, and minus k nu into 0, because the lower limit time is 0, and minus minus plus. So it gives actually a equals to a0 minus k nu t. So I am writing these all the things here. K, what is k? K is the rate constant, and what is a0? Concentration of reactant at time t equals to 0. What is a? Concentration of the reactant at the time t equals to t. Okay, and so now what will be the k? So k equals to what we give, a0 minus a by nu t. This is the formula of k. And so what will be the unit of k? Unit of k in the numerator, this is the difference between the two concentration term. So this is the unit of concentration, and here now nu is basically the number, so it doesn't have any unit, and the unit of time. So unit of time, so what will be the unit of k? Concentration can be expressed in terms of mole per liter, mole liter inverse, and here second. So the unit of k becomes mole liter inverse second inverse. Okay, this is the unit of k for a zeroth order reaction. Now this is the integrated rate law. This is the integrated rate law, or integrated rate equation of the zeroth order. It is the integrated rate equation of a zeroth order reaction. Okay. So my dear students, hope you can write down the things. Next, in the next session, we'll derive the half-life period of a zeroth order reaction. So in our next, we are going to derive the half-life period of a zeroth order reaction. Please write down the things. I am going to remove this. Half-life period. So what is the half-life period for any reaction, for any order reaction, for any reaction? So what will the actually what is the definition of half-life period for any reaction and of any order? It can be zeroth order, it can be any fractional order, because what order of the reaction can be of fraction, can be of fractional values, or it can be of any higher order reaction, first order, second order, or third order. So for any reaction of any order, the half-life period, the half-life period can be defined, can be defined as the time required, can be defined as the time required to consume, to consume half of the amount, to consume half of the amount of the reactant present, present initially. So at t equals to t half, this is the half life period, the concentration, the concentration at the t half, this does the concentration at the t half is nothing but the half of the initial concentration, because half of the amount of the reactant is consumed, so half of the amount of the reactant is left. So this is the amount of the reactant, this is the amount of the reactant left at t equals to t half. So at half life period or after half life period, half of the initial concentration of the reactant is left. Okay. So what will be the guiding factor for our for zeroth order reaction? So for zeroth order reaction, so what will be the zeroth order reaction? K. K for the zeroth order reaction, we get, it gives a 0 minus a by nu t. So when it is t half, a0 is a0, and this is a0 by 2 when this is t half. So at t half we get a t half equals to a0 by 2. Okay. So here this is nothing but a0 and 2 nu by 2. So what will be the t half? So this is the t half. This is the t half of a zeroth order reaction, a0 by 2 nu k. So if nu is the 1, for nu equals to 1, For trigonometric coefficient nu equals to 1, t half becomes a0 by 2k. So look what the important thing, what the interesting thing is that the rate of the zeroth order reaction, though the rate of the zeroth order reaction doesn't depend on the concentration of the reactant, but its half life period depends on the concentration of the initial amount of the reactant. Okay, so I can write here, for zeroth order reaction, t half equals to a0 by 2k. So 2k, 2 new k actually. So 2 new k, these all these things are constant. So t half varies as a0. Okay, so we can write that although the rate of a zeroth order reaction does not depend on the concentration of reactant, its half life period, period is uh, is directly proportional, is half life period is directly proportional to the concentration of the reactant present initially. So this is the main thing, and very often such type of questions are being asked in your competitive exam. So you have to make your concept as hard as concrete. Okay, otherwise you will not be able to answer some typical questions. So to answer these typical questions, you have to make your concept very crystal clear. Okay, my dear students, so today we will stop here, and in our next class we will see some more important subjects and more important topics. Until then, goodbye. And at last, I am telling you, or I am requesting you to please subscribe my channel and do share, like, and comment. If you do have any queries, you can write down in the comment section. I'll get your queries and I'll come back with your solution also. Okay, so till then, goodbye.